I changed the title a little bit. Originally started out with increasing the probability of eureka moments, which is still the topic, only my title is different. This is something that I've been thinking about. This is a topic I've been thinking about writing a book on, and this is actually the PowerPointification of my intro chapter that I would like to send to publishers on this topic. So you'll be seeing this for the first time. Okay, now if you think about ideas as a well, do we use up ideas as we reach into the well? Is there some finite number of ideas? Now think about the first few notes of the Star Wars theme. Everybody knows what those are. I won't ask you to sing it, but you can if you'd like. No, that's fine. Okay. What happens if somebody else comes up with those notes, like after George Lucas, 40 years later? Of course, they'll be probably sued. They'll be laughed at. Once it's composed, it can't be recomposed, except by plagiarism. But musical notes can be reconfigured in a near infinite number of ways. Same thing in visual art. But if you draw the Mona Lisa and try to convince people that it's a new painting, you're in for a career of infamy, and you're not going to make any money whatsoever. And the question is, are ideas in science and technology also finite? There's a sense that each discovery seems to subtract from the pool of future discoveries. And it's a bit like, there's at least an impression that it's a bit like an oil well. So the question is not how to extract new oil from the existing wells and make the person that owns that well more rich, but rather to discover your own well. And I know a lot of us work on green technology, so that's as far as I'll take the oil analogy. But consider the analogy. So this, for example, is a map of Texas, and these are the oil and gas wells in Texas. Suppose this is all of human knowledge or potential knowledge. How do you create a well right here where there's no well? That's really the goal. Like what the ability to increase the chances of discovering a new well portend for the future of humanity, and not to mention your own careers, is actually pretty huge. So if you can learn anything at all in this in the next I didn't even set this. I still have an hour. The next 57 minutes. We'll be in good shape. But so what? Why do we care about this? So innovation has had a huge impact, as we all know as engineers, on the quality of life. So, take some decade before about 1850, or take some century before about 1850. So 1650 to 1750. Sure, we went from the Baroque period to almost the classical period, but really, nothing really changed in terms of quality of life. The life expectancy was still very low. However, from the century from 1850 to 1950, life was transformed by technology completely. We had running water, sanitation, electricity. So these three inventions combined to free women from domestic chores, and which was probably the most significant increase in the overall quality of life for all of society. We had transportation, innovations in transportation. So the invention of the automobile or horseless carriage made it so that horses and the tremendous piles of manure they created in streets didn't have to be cared after and cleaned up. Also, when we watch Game of Thrones, we watch Jaime Lannister ride off to the north over thousands of miles with his horse, but that didn't happen. He had to change his horse out many, many times. We don't really do that with horseless carriages. Innovations in healthcare, antibiotics. Antibiotics arose within the last 100 years. That's crazy. Vaccines. All of these things, however, have the characteristic that they could only be invented once. So once you pull the vaccine out of the well of ideas, it can't be invented again, and you don't get that improvement in quality of life again because you can't reinvent these things. There are a lot of modern inventions that have occurred since 1950, like the computer, internet, smartphones, self-driving cars, genomics, artificial intelligence at various degrees. So it still needs to be developed. But do they represent, the question is, do they represent the same potential for the increase in quality of life that we saw given these basic technological innovations like running water, sanitation, and so forth? Now that's arguable. Some people would say, especially now, there's a big backlash against staring at smartphones and social media and how we didn't really evolve to do those things, and how it's really increasing our adrenaline and cortisol, and in fact in the United States, nothing to do with social media probably, but life expectancy is actually decreasing for some segments of the population. There are consequences to stagnation, and I'm not going to give you some capitalism, jingoism for capitalism here, but the fact is we are living in a capitalist society, and it's built on growth. If you stagnate, if the economy stagnates, that's equivalent to loss. So unless human nature can be changed, stasis is really unsustainable. And I'm only stating facts here. I'm not making a value judgment on a philosophical or political system. In fact, I wish that we could smell the roses a lot more than our species seems to be able to. But since World War II, there's been an exponential growth in the R&D workforce, yet a decline in something called the total factor productivity of the economy. I'm not an economist. Somebody here probably knows what TFP means more than I do, but it's basically the strength of the economy, the ability to increase our production, incorporating as many factors in the economy as possible. And if you look at the growth in the R&D workforce, it's exponential. This is since the 1930s. But if you look at the increase in total factor productivity, it's actually going down. So this means that each marginal invention is not adding to our economic strength. It means that the amount of effort we're putting into the R&D workforce is not actually making us better off, apparently. If you want to learn more about this, I suggest reading the book Rise and Fall of American Growth by Robert J. Gordon, who's an economist at Northwestern. So the question is progress steady? Clearly not. Clearly not from the plot on the last page. So I have a theory about this, that our perception of events and our own character even suffers from a fallacy of a mean field or continuum, that we kind of think, well, we are X amount creative, or our economy is more or less strong, so things will just keep getting better. That we're a nice person, so automatically everyone will like us, even though on those 3 instances in which we met somebody, we happen to be a jerk, and therefore they hate us. So what this tells us is that discrete events are actually the power in not only personal relationships, but also discrete events like invention of new technology. So for example, invention of the CRISPR-Cas9 gene editing technology didn't happen simply because we were creative and things just get invented at a steady rate. It happens because somebody invented it, or the state of affairs was such in the, if you want to be fatalistic about this, conditions were such that it was invented. So my hypothesis, however, I think that there is a way out of this, and to increase the number of discrete events that lead to technological discovery, is that it's possible for individuals to increase the rate of knowledge generated in a society by adopting a relatively small number of behaviors which, while they may have been stumbled upon in the past, are actually possible to learn. So I'm going to probably be devoting from now, when I started thinking about this, to the day I retire, in figuring out, in trying to validate this hypothesis, because the stakes really couldn't be any bigger. Also for my job, I mean, I'm a professor, I have a research group. If we can create more innovations, I mean, my motivation is not entirely selfless, let's say. What is technological innovation? So tech and innovation are words that are thrown around a lot in the media. We're talking specifically about innovation in science and technology. Science is, why do I have to say this? Probably before I really thought about it, I probably couldn't have come up with this definition, even though it was taught to me in 5th grade. Science is the creation of knowledge using observation, hypothesis, and experimentation. Creation of knowledge. It bears a resemblance to everyday forms of rational behavior, like cooking, except that science differs from everyday rational behavior in that it requires access to techniques, exceptionally large or hard to obtain data sets, or perhaps instrumentation that elude our everyday experience. So say science in the field of microbiology, we can't see things with our eyes that we would see with a microscope, so we use those to do especially rigorous forms of experimentation and observation. What does this mean for like an archaeologist? Well, you need access to go dig up artifacts, or paleontologists to find bones, for example. These are things that we bring into our machinery of rationality, but we derive these tools and these data sets from exceptional sources. What's technology? Technology is the application of science to solve a problem in a physical embodiment, such as a device, like a solar cell, a process like gene editing, or algorithm like in internet search. Science and technology innovation using science and technology is creating a new paradigm. To me, this is what innovation means as a scientist, engineer, technology person. Means that we're creating a new paradigm using some new physical effect. So the crux of this is that not all innovation in tech qualifies as an innovation in technology, in my opinion. The iPhone and the Uber are, the Uber sounded like I was 100 years old. The iPhone and Uber are transformative, but perhaps not as transformative as, for example, the transistor. So sometimes innovations in the tech industry are really innovations in marketing and sociology, not necessarily because of the discovery of new physical effects. That's fine and that's important, but that's not what we're talking about here. And I would argue that innovations in science and technology in embodiments like electronic devices, biomedical processes, or computational algorithms are more fundamental than just a sociological innovation like Airbnb, as transformative as it certainly is. And I think the purest form of technological innovation demands a discovery of new scientific knowledge, creation of new scientific knowledge. So there is something called the Thiel Fellowship. Peter Thiel is the co-founder of PayPal, along with Elon Musk. And he created something called the Thiel Fellowship, which was very controversial. And the idea was you give a cohort of bright high school students $100,000 so that they get this money, they don't go to college because some ideas can't wait. Now what is a high school student going to do with $100,000 if they don't have differential equations or calculus. Yes, they can come up with innovations in marketing and sociology. They could come up with the next app for sure, but they're not going to come up with the next transistor or the next CRISPR-Cas9. And I think this is ironic coming from Peter Thiel, because he had the famous quote that the tech industry promised flying cars and instead we got 140 characters. What can the Thiel Fellowship accomplish except give us another 140 characters? I know now 280, whatever. So here are the strategies. So there are 7 of them. Why 7? I don't know. 7 is I guess that's the largest number you can count just by looking, so I'm told, without breaking it into smaller parts. So there are 7 of them that I could think of. The first one is eating your vegetables. So there's no get-rich-quick scheme here. There's no substitute for knowing your stuff. Why? 3 reasons. The first is that you have to be able to understand what people are talking about. That seems obvious, but there's this notion, well, there's this truism that when smart people talk, there's a whole layer of complexity below what they're saying. Like, you can understand the actual words that they're saying and they make sense coherently, grammatically, you can understand, but if you know about what they're talking about, then each word that they use has this cascaded levels of complexity beneath it. And if you know what they're talking about, you can derive much more benefit from it. In those of you who are CSE people know about the concept of effective complexity. So a description of a system's regularity. And so say a JPEG or an MP3 has high effective complexity because knowledge is being assumed on the part of the decoder. And in the case of a human being, this would be the reader or the listener. So if you go to a TED Talk, but you did your PhD in that topic, there's a lot more complexity in just those 18 minutes than just someone who has no idea, who had no idea coming in what the TED Talk was about. You find this all the time when you re-listen to songs as an adult that you originally heard as a child. And although you might have known what all the words are, assuming you could discern, what the words are. I used to think that in the Phil Collins song "Land of Confusion," the line "not much love to go around" was "not enough snot to go round." But anyway. That was a nicely timed throat clearing, whoever that was. Okay, and assuming you actually do know what the right words are, you get a lot more out of it with the reflection of an adult as opposed to a child. The second reason there's no substitute for knowing your stuff is because in order to discover something, you have to know that it hasn't been done already. And this is textbook knowledge plus knowledge of the state of the art. And I would argue that there are more and less efficient ways of learning the state of the art. Going to seminars, you might be able to learn the content of 5 papers as opposed to reading 5 papers when you may have to pick it apart with a fine-tooth comb in order to figure out what exactly the people are saying. Talk to people, talk to others. The third reason there is no substitute for knowing your stuff is that the more you know, the more it's possible to know. There is a famous economist at George Mason University named Tyler Cowen who has a really good podcast. I would highly recommend it. And he's a notoriously or famously fast reader. And he reads books. He's not a speed reader. He didn't take the class for $199.99 that's advertised at 3 a.m. on your local Fox affiliate. But what he did do is read so many books that he can kind of look at books and pages of nonfiction books and sort of pick out the arguments that are new to him. And when he reads a book in 2 hours and someone says, "How long did it take you to read that book?" And he said, 52 years because he was 52, and yeah. The more you know, the more it's possible to know. The more knowledge you have, the more bins you have in your mind to sort out new knowledge. You want to take another analogy. It's like connecting the dots. Connecting the dots is easier if you have more dots in your head to connect. Sometimes, most of the time, I don't feel very gifted. But you can overcome people that you're like, oh, that person's smarter than me, that person's smarter than me, that person's smarter than me. Because they talk fast, they seem to always have the right thing to say. They kind of make you feel not very good about yourself when you're in their company. But you can overcome the effects of other people's gifts just by knowing more than they do. To that end, memorization and fact are not dirty words. There's a kind of a backlash against this idea that why do we have to, or knowing facts is so 1990s because we can all just look stuff up on Google, but you don't get all the benefit of all this other stuff if, say, in a meeting, somebody says something, say in an art science meeting at your next company or in a university or next research group, and somebody says something that you think is false, and the whole team is about to go on this garden path or waste a lot of money, and no one's going to have the patience for you if you say, wait a minute, that doesn't sound right, let me Google it. So knowing stuff allows you to become dangerous in any situation. Okay, the second strategy has to do with the place between disciplines. So how are we going to increase the amount of the density of eureka moments in the chatterbox, which is my head and probably a few other people's heads in the audience. So disciplines, what are those? Like biology, electrical engineering, chemistry, physics, chemical engineering. The names of the sciences and departments are historical accidents. F equals MA no matter what department you're in. Physics and chemistry, or plot energy using either wavelength or energy, which gives you the mirror image, which gives you an inversion of the plot depending on what seminar, what department the seminar you're in is hosting the seminar. Why does this have to be? It's really because these fields had different historical antecedents. So even within graduate programs, subdisciplines live in silos. You're part of the circuits group, or you're part of the fluid mechanics group, and maybe you don't even go to each other's seminars. Maybe you're in a department and you only go to the nanomaterials for drug delivery, specifically for cancer drug delivery. They have their own seminar series, coursework, and sometimes beer hours, but not at UCSD because you need a permit for a beer hour. And I think that this tendency to call ourselves whatever academic discipline that we are evolved from our kind of propensity to form these group identities. Oh, I'm a fluid mechanician. I'm a fluid dynamicist. I'm definitely not a quantum mechanician. I would say that hyperspecialization leaves vast unnamed spaces between these disciplines. Oh, there's a typo, sorry. The lacement, the placement of one's creative work between disciplines has the power to unlock tremendous potential for discovery and to create immense value. And the good thing about doing this, the good thing about deliberately choosing spaces between disciplines, so taking, not to pick an example from my own lab, but the intersection of psychology and material science, allows you to have reign over that discipline for a long time before people catch up. So you can monopolize and capture all the value that you create by monopolizing that field until people catch on, if it's a good idea. But if it's new, it has a much better chance of being a good idea than if you're just redoing the Mona Lisa. Okay, if you're the originator, you can claim credit and then move on to create the new field and capture all of that value. Why do you want to capture value? Because you believe what you're doing is the right thing and you want resources to do the next thing. The advantage is that this strategy rewards strategic choices as opposed to just luck. Like, is this idea just going to bubble up? But the downside is that you need to have the intellectual and financial freedom, so that you need to be in the place that's going to give you this freedom to survive long enough in sort of the rough, unexplored waters, and people think that your ideas are all crap, until they start to be recognized, and then you can actually start to create sort of an island between these safe shorelines. Strategy 3 has to do with your friends and colleagues. Innovation suffers in a vacuum. I think that conversations can be the source of new ideas. People can say something to us that triggers our imaginations. People can encourage us emotionally and help us reject our own bad ideas. That's really important. Like, there's nothing more reinforcing of good ideas than the ridicule of bad ideas. Or perhaps encouragement to reconsider that idea. A great friend or colleague ideally is somebody smarter than us, but in front of whom we're not worried about saying something stupid. Individuals who get the best and worst out of us are those who can help us decide which is which. So the individual who says, who you're not afraid of telling a bad idea to with the hope that eventually you're going to say something good, they can help you parse these things. They can help you sort the wheat from the chaff. So also, ideally, this person is not only somebody that you don't feel bad embarrassing yourself in front of, but also they're not exactly in our area of expertise, but with whom we can actually learn to speak the same language. So little practical advice here. It may be possible to do a Vulcan mind meld with these people and share our thoughts directly, but more often than not, it requires some food and possibly drink to get the good stuff out. Bring a notebook when spending time with these most valuable people. Ask questions and don't be afraid to be stupid. Okay, flow has been in the news a lot. What's flow? So flow is when your undistracted creativity is at its most powerful. Oh, that font is really small. There must be a lot of text on this page. I'm sorry about the text. It's so that when I put it on YouTube or I send out the slides, you kind of have everything. Okay. Undistracted creativity is at its most powerful. You ever been so consumed in a task that you lose track of time, or you don't go to the bathroom for 5 hours? So conscious effort is required to discover ways of increasing the probability that you enter into these flow states. And it increases your chances of discovery and innovation if you can figure out what allows you to enter into these flow states. So it's not always easy to find the way to do this, but there are certainly ways of not entering into flow states. And they essentially all of them involve some form of distraction. And if you've been to my talks at this series before, you're probably familiar with these. But shut off your phone or put it into night mode where you won't be distracted by texts. Shut down unneeded applications on your computer, especially your email program and your web browser. And you can accomplish this quickly without even reaching for the mouse by typing Control-Q or Command-Q for Mac users. The likes that you've collected on Facebook and the retweets on Twitter will still be there when you get around to seeing them. This is something that I tried doing recently, and in fact, I wrote this entire slide presentation longhand, and I did it on a plane, in part because you're not allowed to use large portable electronic devices during taxi takeoff and landing. So rather than put a notebook down and get my laptop back out, I just wrote the whole thing in a notebook. And it actually made the flight, this was from San Diego to Washington, D.C., pass by like faster than any flight I've ever taken. Okay, so consider doing this if you don't need constant access to electronic resources. Like if it's a pure creative thing, like writing the intro and discussion section of a paper or a proposal or a long email. For further reading on the topic of getting your flow on, there's a classic, Peter Drucker's The Effective Executive, Don't Let the Name Throw You. It's all about doing effective things in creative processes and knowledge work. Stephen Covey's The 7 Habits of Highly Effective People. There are 7 of my strategies. There are 7 of this guy's things. I don't know, maybe I was influenced. Probably not. Probably yes. Clearly I was. Cal Newport's Deep Work. It's kind of like a long blog post. It's not really that scholarly necessarily, but he says a lot of useful stuff. Tim Ferriss's, I think unfortunately titled book, The 4-Hour Work Week. If you ignore all the stuff about sipping mojitos in a hammock in Thailand, if they drink mojitos in Thailand, then you can, there's a lot of good stuff in here. And Peter Diamandis, who's the founder of the X Prize Foundation, and also one of the co-founders of the Human Longevity, with Craig Venter, wrote this book, Bold, which is quite good. Okay, this is the controversial slide, but I'll keep it uncontroversial for the sake of my job. Okay, somatic enhancement. So sometimes we're not at our most creative, just in our normal 6.5 hours of sleep and rolling out of bed with our alarm, and we don't feel that creative. There are bills to pay. There are all kinds of stuff that we need to do to keep our head above water in our everyday life. So there are the standard things: sleep, exercise, diet, caffeine. Some people find this inspiring. Who finds caffeine inspiring? Okay. One time, so I have a caffeine intolerance. I know this because I know it, and I know it because it was reinforced by using 23andMe. So I spit into a vial and sent it to this company, 23andMe, which will do your single nucleotide polymorphism genotype, your SNP genotype, and it told me that I had slow caffeine metabolism. Now I knew that I had slow caffeine metabolism, but it was really important to get my SNP genotype in order to tell me what I already knew. And there were some other good things in there too. Not actually super good, but it was all right. So as a result, I don't drink that much coffee. When I do, it's decaf, and it's generally not when I'm speaking in front of people. Like today, for example, I had 1 dark chocolate square, and that was enough caffeine and theobromine to give you what you see right now, this energy level. And I one time, this was the summer of 2014, there's this grant program from the NIH called the New Innovator Award, and it's really the only proposal mechanism that materials engineers or electrical engineers really, as a young faculty, before being able to apply for R01s and R21s and having enough preliminary data, have a chance to get. And it's also a huge amount of money. It's like $2.2 million, and 1.5 million of that is direct costs. It's like fantastic opportunity. And I didn't have anything on the schedule that day. It's pretty unusual, but it was the summer, so not that unusual. So I went to Fairbanks outside here, the one that the same exact one that was arsoned last year, and I got a fully caffeinated, small, like a single shot, fully caffeinated latte. And then I went totally crazy and decided, oh, look at that NIH New Innovator Award. I think I can apply for that. I think I've got enough. I think I've got enough preliminary data. I think I can probably come up with a good idea. No one's going to come up with a better idea than me. And then I just belched everything right out on a page. And this is after applying for 11 NSF grants and getting the first one, and then getting 10 rejections in a row. And so I was kind of grasping at straws here, and I kind of owe eventually getting that grant to the latte trip. And some senior scientists have been a little bit more crazy. This is Kary Mullis. He won the Nobel Prize for somebody said it, PCR, polymerase chain reaction. And he published this book with this somewhat appealing photo of him in a wetsuit on the cover. And he was known for, among other things, doing a bunch of substances and seeing fluorescent raccoons. Whether or not that had anything to do with his discovery of PCR, I don't know. You could ask him. All right, strategy 6 is to know thyself. Who's this? You know who this is? Alton Brown, also known as the cooking guy. So he is the host of Good Eats on the Food Network, and also also Iron Chef America. He didn't start out as a cook. He decided that he was bored with his day job in his mid-30s, and that he was going to go to cooking school because he really enjoyed the genre of food TV. But he said that all these shows, I can do it better. I can do it in a much more entertaining, informative way than just the camera on somebody, in front of a counter making food, a la well, Jeff Smith and Julia Child were good, but there are definitely some cooking shows that were not very good. He said, I can be better than those. So he dropped everything and he went to cooking school. There was this, I saw this interview now 11 years ago on this now defunct show called The Big Idea with Donnie Deutsch that used to be on CNBC. And it stuck with me forever. And I didn't unearth this interview. I remembered very key phrases from it, but I didn't unearth it again until actually 2 hours ago when I was putting this slide together. And he said this. So Donnie Deutsch asked Alton Brown, what do you do? What advice can you give someone else who wants to really innovate, to do what you did? And he said, well, you have to step outside yourself and make a realistic assessment of where you stand compared to your competitors, because you are about to become a product. And I would argue that your ideas, so your creative ideas, are kind of like Good Eats, and you and your ideas are really a product. So you have to have some idea of how you stand and how your skill sets stand in relation to others, so that you know which skills to push on and which to hold back on. Let me develop this theme a little bit better. You can't be good at everything. So just in full disclosure, my skills do not include math and programming or virtually any quantitative science whatsoever. I'm good compared to the average person, but not good compared to the people in this room, I guarantee. Materials intuition, that I'm pretty good with. I'm pretty good at with knowing the behavior of atoms and molecules. And I'm pretty good, you can judge based on this, that's fine. Communication, storytelling, I didn't rehearse this too much. Figuring out the sharpest arrow in your quiver and pushing on that. So don't do something that you know most people are better than you at, because I mean you have to do it to survive. Like if you do any kind of science or engineering at all, of course you have to do math, but maybe you're not going to be the one to come up with this particular kind of algorithm or model, but there's an aspect of the project that you can do better than anyone else can. And I think discovering what these skills are is a meta skill. That is knowing your skills relative to the skills of others, and that is really important because you don't want to become second best in somebody else's game. I think that's a pretty sure path to failure. So this means saying no to a lot of things. So a lot of opportunities are going to come up that are not really what you do, not really the thing that makes you special. And you probably want to say, you're going to have way more opportunities in life than you can possibly, or in a position than you can possibly say yes to. So you have to say no to a lot of things so that you can use your considerable creative energies in the areas that are already your sharpest attributes. Strategy 7, I know I said luck wasn't a strategy, but it kind of is. For me, insights can't be willed into existence. As if I were to say, oh, I really wish I had that new intuition on flexible electronics. So I'm just going to sit here and grit my teeth and hope that it pops into my mind. That's just never going to happen. So the conditions have to be right. In my experience, insights bubble up periodically as a function of experience, knowledge, alertness, and conversations with others, and the absence of anxiety. Are these a result of random fluctuations in the brain? Depends on how you define random. I think you can create the conditions that are more and less conducive to these insights arising. So luck isn't a strategy, but putting yourself in the best possible position to capture insights from events outside of your control can be a strategy. So we're talking here about casting a larger net to be lucky. Louis Pasteur said, chance favors the prepared mind. And that would be another way of summarizing the last 42 minutes. So set into motion events whose outcomes are out of your control, but from which you may still be able to capture some intellectual value. So if you want to use a hockey or soccer or football analogy, take more shots on goal, and in the entrepreneurial community, they call this failing fast, fail fast. So crazy random idea may either cave in or be reinforced by having to explain it. So this goes back to the idea of being around company that you are comfortable being stupid in front of, comfortable, telling your crazy random ideas to. And if it's not too crazy, it will be reinforced by conversation as opposed to caving in under conversational pressure. In the lab, you can't test every hypothesis, but you can falsify it quickly with an acceptable level of certainty relatively quickly, either in the lab by doing quick experiments which eliminate most of the uncertainty quickly, or in conversation. So conversation with somebody that knows something about the topic in which you have an idea or a hypothesis might be the easiest way to test it because they might know something that you don't. A Nobel Prize winner he's actually a psychologist, but he won the Nobel Prize in economics. His name is Daniel Kahneman. He wrote a book which I would highly recommend, Thinking Fast and Slow. He said, okay, well, it's still in the back. Oh, there it is, okay. In Thinking Fast and Slow, that if you don't fail regularly, you're not taking enough chances. So we think of failure as a bad thing, but if you look at it from the standpoint of, say, batting average, like sometimes if you're into baseball, like I was for much of my life, but now we have the Padres, so there's less of that. Sometimes you'll see the batting order, and you'll see that someone has a batting average of 1,000, which might be like a relief pitcher who got up to bat and had one lucky hit, and that was the only at-bat they ever had. So it's wrong to assume that that person is a good hitter, whereas someone that has a 300 or 30% success rate at batting, that person fails 70% of the time, but they are regarded as a good hitter. They're much more productive. So failing regularly is actually a sign of effort, because you'll never get the things that you don't try for. I'm going to put this on YouTube. This is my channel. And I guess I forgot that was the last bullet point. But Daniel Kahneman's a great place to end on. So if you don't fail regularly, you're not taking enough chances, I'm happy to have any kind of discussion because we have a few minutes left. Thanks.